Okay, so part 2 of section 2.3 is quotient rule. So quotient rule is a little more confusing. Basically, you have in your function, you have a function on top and a function on bottom. They call them f of x and g of x. So in this one, f of x is 5x minus 2, g of x is x squared plus 1. So what you do when you do the derivative of it, so they call this low d high minus high d low. So let me tell you what that means. So low is your bottom function, so g of x, and then d high means the derivative of the top. So low d high minus high as is, so there's your top function, d low, which is your derivative of your bottom function. So low d high minus high d low all over low squared. So g of x squared. Now, the order in this one does matter. So on product rule, you could have switched these around and did the derivative of the opposite one. And because they were adding, it didn't matter. In this case, it totally matters because of this minus sign right here. So be really careful. It has to be low first. The way that I always remember it is this is always low squared. So you always start with low here. So low d high minus high d low. So high and low are there and there. Okay, so let's try this one. So y prime is going to be low. So I'm going to start out with my x squared plus 1 times the derivative of the high. So d high. The derivative of 5x is 5. The derivative of this minus 2 is 0, so it's just 5. Minus high as is, so 5x minus 2, times d low. D low would be 2x. All over low squared. Now what you'll find is typically what they will do is just leave this one alone and simplify all of this top part. So that makes it a little bit easier. So let's just kind of simplify this top. This would be a 5x squared plus 5 minus, if I distribute this, this would be a 10x squared and a plus. So this minus sign, be careful with that. You've got to distribute that and you have to distribute that. So this is going to be a 4x, but a minus and a minus makes that a plus 4x. And then my bottom, I'm just going to leave the same, x squared plus 1 squared. Okay, so that means my final answer here, let's get this together. So this would be a negative 5x squared. And then this would be, put your x next, so plus 4x and then plus 5. Just so that everything's in descending order. And then I'm just going to leave this alone, x squared plus 1 squared. And I would just stop right there. That's as simple as you really need to get. So eventually what's going to happen is we're going to have to start thinking about where there would be asymptotes and things like that. So we need to think about the top and the bottom set equal to 0. This format right here, this much simplifying is all we really need. So we're good. Okay, so this one, example 5, they asked me to do a little bit more on this one. They said, find the equation of the tangent line. So if you remember back, the derivative is the slope of the tangent line. So if I find the derivative of this, and so in this case, I found the derivative, but that's a general solution. They didn't give me a point to plug in. So I didn't have to worry about plugging any numbers in for x. On this one, they gave me an x and a y. Really, all I'm going to need is the x. So after I find that derivative, I can plug that in and find the slope at a particular point. So that's going to give me my slope of my tangent line. Well, in order to write an equation, I'm going to need this. So I'm going to need that slope that I just talked about, but I'm also going to need a point, my x1 and my y1. Well, they gave me that already, so this will be my x1 and my y1. Okay, so let's start with the slope though. Now this is messy. Anytime they give you something that looks messy like this, I would do your best to clean it up. Technically, if you really wanted to, you could say that this is x to the negative 1. But if I do that, I'm going to have that exponent of -1 throughout that whole problem, throughout this whole process. And I don't really want that to happen. So what I'm going to do instead, I'm going to clean this up and say, what if we took this whole thing times x? But if I do it on the top, I have to do it on the bottom. So I'm going to just fix this and say this is really 3x minus, that would just be 1, over, this would be x squared plus 5x. This is a lot easier to deal with than this weird situation. So if you can make it easier on yourself, please do. So now I'm going to do my derivative. So f prime equals low d high. Well, the derivative of that top part would just be 3. So the derivative of 3x is 3. Minus high d low, which would be 2x plus 5. So this I'm going to have to distribute out. And then all over low squared. Okay, so then I'm going to try to simplify this as much as possible. So this is going to be 3x squared plus 15x minus, now this is where I need to be careful. I'm going to go ahead and distribute this out right here. So this would be 6x squared, and then this would be plus 15x. So I'm not distributing this minus sign yet. This would be minus 2x, and then this would be minus 5. So really I have 6x squared plus 13x minus 5. That's what all of this is. Now I'm going to distribute that minus sign. So that's going to give me a minus 6x squared minus 13x plus 5. All over x squared plus 5x squared. Now I'm going to combine what I can. So this would give me a negative 3x squared, and then a plus 2x, and then a plus 5, all over x squared plus 5x squared. Okay, so now I got to figure out what's happening at this point. So at -1, my slope would be -3 times -1 squared plus 2 times -1 plus 5 all over -1 squared plus 5 times -1, all of that squared. Okay, so let's simplify that then. So this gives me 1 times -3. That's -3. And then 2 times -1 would give me a minus 2, and then plus 5 just kind of stays put. This down here would give me a 1, and then a minus 5 squared. So that means I've got, this is -5 plus 5 is 0, over, this would give me -4 squared, which is 16. Well, that means my slope is 0. So the slope of my tangent line is 0. Okay, so now let's think this through. So if I have my y minus y1 equals m times x minus x1, let's plug those values in. So I've got y minus, my y1 is 1, my slope is 0, and then my x value is -1, so minus -1 is really plus 1. But if I take 0 times all of this, I just get 0. So this is really y minus 1 equals 0. Or I could say y equals 1. So this is the equation of that tangent line. So it ends up just being a horizontal line going through the y-axis at 1. Okay. If that had been anything other than 0, I probably would have just left it in this form. But with that being 0, I went ahead and made it in more of a slope-intercept form type of situation. Okay, so then let's talk